So, good evening to everyone present. My name is Joel and my topic is electrochemical grinding. So, electrochemical grinding is modification of both the grinding and electrochemical process. In this process, machining is affected both by the grinding action and by the electrochemical process. Hence, in true sense, it's also called as mechanical adjusting electrochemical machining. And in electrochemical grinding, the metal bond grinding is filled with non-grinding abrasive. The grinding wheel acts as a cathode and workpiece acts as an anode in this process. The remaining electrolytes are used such as sodium nitrate and phosphate, and the concentration of water used is 0.150 to 0.300 kg per feet cube, and it passes through nozzle and in this machining zone to complete the electrical connection between the anode and the cathode. The work in the wheel do not make contact with each other, and both are kept apart by inserting abrasive particles which proceed from the face of the grinding wheel, and the gap is provided so that there is no joining or like a connection between those two, between the work and the wheel, so it does not collide with each other and does not cause any problem during the process. And the electrolyte is carried past the work and rotation grinding wheel is done, and is done. And the rotary action of the grinding wheel takes place, and rotational grinding wheel metal is removed from the workpiece for simultaneous electrolytic abrasive action. Abrasive grindings range on the surface of the wheel serves to act as a paddle which picks up the electrolyte and cause pressure to build at the work area. The parts of the electrochemical machine are electrolyte delivery and circulating system, DC power supply, grinding wheel and workpiece. An electrolyte delivery and circulating system. The electrolytes are not totally immersed, there must be an ample supply of electrolyte. Nozzles are used to ensure proper rating of action of the wheel. And nozzle creates a partial vacuum cause electrolyte to be sucked up, filling the cavities around the grid. The rotation of the wheel then carries the electrolyte into the area of contact between the workpiece and the wheel. DC supply. According to Faraday's law, the quantity of chemical change occurring in electrolyte is directly proportional to the amount of current passing the electrolytes. And in this process, both the types of electrical energy are used, that is both low current voltage and high current electrical. And they are properly designed DC power supply and to the electrochemical grinding process. Grinding wheel is used as cutting tool as a cathode, and the workpiece anode, which is told as before, and the same fluids are pumped into the space between the workpiece and the grinding wheel so as to ensure proper grinding. And the workpiece is done here. And the types of process and grinding which can be performed are phase grinding, surface grinding, internal grinding, form grinding, cylindrical grinding. The single largest used for ECG in the manufacturing and remanufacturing turbine blades, and they are even used in grinding, reprofiling one locomotive traction motor gears, and the high MRS turbine when grinding hard, tough, stringy or hardenable or heat sensitive materials. Now let us see video of electrochemical grinding process. So this is taken from Everly, and this was for electrochemical grinding. So the solutions are inserted and grinding takes place. So this is how the supply takes place. This is the supply. This is the brush which acts as a cathode, and this is the supply is a positive. This is the commutator, and this is the spindle which rotates. And the grinding wheel is attached here, and the electrolyte supply is given underneath, and the table is the table or workpiece. These are the buttons which are used for the process in grinding and used in stainless steels, nitinol and other medical alloys. So thank you.